Hello everyone. Looking at Chapter 2 Study Guide, I told you I'd post kind of a review of me working over several problems, so I wanted to do that. Sorry I'm posting a little bit late, but looking at starting with number 1. First thing we want to kind of look at when we're dealing with vertex form is know what vertex form is. Vertex form is y equals a times the quantity of x minus h squared plus k, where h comma k is the vertex. Well, if you notice here, this is what we have here, but our A is 1, our H is 3, and our K is 1. So our vertex here is just simply, this is in vertex form, so our vertex is just simply 3, comma 1. It's always opposite this sign, okay? It's always opposite that sign, so I got to point at 3, 1. And then I'm going to look at my A. What is my A doing? Well, since there's just a 1 there, it's just kind of following a way to think about this is to say, okay, I have taken care of the minus 3 and the plus 1. Now I just have x squared. So something you could do is just think, okay, from that point, I just need to post my points for x squared, which are 1, 1, 2, 4, 3, 9. So I can go right 1 and up 1. Right 2 and up 1, 2, 3, 4. Right 3 and up 9, which it won't let me. And then likewise, I can have this little axis of symmetry right here. And then I can just kind of plot the points on the other line, giving me a graph that looks something like this right here. Again, you're going to have multiple choice, so your main thing is making sure you understand the vertex, and then secondly, making sure you understand your different points within that. So, and again, if you have any questions, you can talk to me tomorrow briefly. Use the information provided to write the vertex form of the equation. So now it's given us this graph, and now we got to write in the equation f of x is equal to a times the quantity of x minus h squared plus k. Well, the first thing we need to find is the h and the k. What is the vertex here? Well, my vertex here is right here, 6 comma negative 5. So 6 comma negative 5. So when we plug that in, we got f of x is equal to a times the quantity of x minus 6 squared minus 5, which is what we want. Now, the only thing we need to find is a. So finding the vertex gives you h and k, okay? Then you got to go find a by looking at the points, okay? So again, a couple different ways you can do this, but I'm doing it like this right here. I want to see, okay, it's going right 1 and up 1, 2. So right 1 and up 2. Right 2 and up 1, 2, 3, 4, 5, 6, 7, 8. So right 2 and up 8. And we know these, and we should know that, well, x squared is 1, 1, 2, 4, 3, 9. Well, look what's happening here. It's going 1. No, it's not 1, 1. It's 1, 2. It's not 2, 4. It's 2, 8. So it appears the y is being multiplied by 2. So that would lead us to this to being 2x squared. So our a is just simply this. So f of x is equal to 2 x minus 6 squared minus 5. Now, the unique thing about this was, well, if it was like this right here, what if it was 1, 3, 2, 12? Then we would know it's 3x squared, and the a would be 3 then. So kind of look at the parent function, and then base your points on that to determine what the a should be from there. Okay. So therefore, my final answer should be this right here. And again, check with your answer key that I provided for you. Looking at number 5. So identify the vertex of each. So this is a pretty big deal. You got to be able to find the vertex of quadratic equations in order to graph them. So in order to identify it, it's opposite b of 2a. This is how you find the vertex. You need to know this information, okay? How you find the vertex is negative b over 2a, where we got a, b, and c. So I got negative 24 over 2 times negative 2, because b is negative 24. It's opposite b, so that would actually be a positive 24. I'm sure I'll make mistakes. You can tell me about them whenever I see you again. So we got 24 over negative 4. Well, 24 over negative 4 will lead us to negative 6. So my h coordinate of my vertex is 6, or excuse me, -6, comma, and now I just got to find my k. Now how I find my k is by taking this and plugging it back into x. So -2x squared minus 24x minus 81. So that'd be -2 times -6 squared minus 24 times -6 minus 81. So that'd be -2 times 36. 20 times 6 is 120. So that should be positive 144 minus 81. Double of 36 would be -72. -72 plus 144 minus 81. -72 plus 144 would take us to, I'm pretty sure, 72. 72 minus 81 would take us to -9. So I'm looking at a vertex of -6, -9. So that's that. And our again, this right here is your answer, not the -6, or it's the -6 and -9 together. All right. Solve each equation by factoring. So for solving number 7 by factoring, the first thing we got to do is multiply a times c. So multiply a times c. So a times c is 1 times 1 is 1. The only multiples of 1 are 1 and 1. Will 1 and 1 add to be b, which is 2? Your answer is yes there. So what we can do is we can rewrite that. All right, so we can rewrite that as a squared plus a plus 1 equals 0. So if you notice here, I just rewrote 2 as a plus a. 1a plus 1a is 2a. Now from there, I can factor by what we call grouping. I can pull something out of each pair of groups here. So a and a, I can pull a out. If I pull a out of a squared, I'm going to get a. If I pull a out of a, I'm going to get a 1. And then I can't really pull anything out of a plus 1, so I'm just going to pull 1 out, and I'm going to say a plus 1. Once I get that there, I then go to, I then can put these two together and say a plus 1 times a plus 1, which this is a perfect square. So we can say a plus 1 squared equals 0. And then if you know how to solve from there, you just say a plus 1 equals 0. You don't have to put the square. We subtract 1 from both sides, and a equals -1 there. So to solve that, our answer is a equals -1. That one was pretty simple. And again, if this leading coefficient is 1 here, you can just automatically set your parentheses up, set it equal to 0, put your variables there, and when we said 1 times 1 was 1, and whatever multiple is multiplied to be 1 but add to be 1, or add to be 2, your middle term, you can just put those numbers right there. And that's just kind of an easy trick, which would kind of lead you to your answer, so you don't have to group or anything like that, but that's still factoring it. So because the leading coefficient is 1 there. All right, let's look at 9. Again, multiply 2 times -9. 2 times -9 is -18. So again, that's 2 times -9. And if I'm looking at -18, I have to determine what will multiply to give me -18, but somehow add to give me 3. Well, I got 1 and 18, 2 and 9, 3 and 6. So if I'm trying to figure out, well, 1 and 18 will not add to be 3, so that won't work. 9 and 2, I can't say 9 plus 2 or 2 minus 9 or anything like that to get to 3. But 3 and 6 will work. One of them has to be negative in order for the product to be negative here. So if you're just looking at this, if I say -3, well, -3 plus 6, will that give me +3? Yes, it will. -3 plus 6. Or another way to think about that is 6 minus 3. To kind of just think about it in that. And so I'm rewriting that 3x, 2x squared. And I'm going to put the 6 with the 2 because they're, obviously they're divisible. So I'm going to say 6x and then minus 3x minus 9 equals 0. Now, if you notice what we've done here is we have rewritten this middle term 3x as 6x minus 3x, which is 3x, but this allows us to factor by grouping. So now I can underline these two and say, all right, I want to group these. So what number can I pull out of 2 and 6? Basically, what's the least common multiple of 2 and 6? Well, 2 is. Because 2 will go into itself and it will go into 6, so it's the least common. Then look at your x's, x squared and x. What's the least common? They both have an x, so we can pull an x out. Well, and then I draw my parentheses. If I pull a 2x out of 2x squared, the only thing I'm left with is just an x. If I pull basically, and I'm saying divide basically there, so think about that as 2x squared divided by 2x. Your 2x cancels, but you're left with just 1x. 6x divided by 2x would just be 3. And then over here, I can pull a negative 3 out. If I pull a negative 3 out, I'm going to, and I can't pull x out because negative 9 doesn't have an x. I'm pulling a negative 3 because that will go into negative 9. Well, if I say negative 3, x divided by negative 3, I'm just left with x, and negative 9 divided by negative 3 would be plus 3. And that equals 0. Your key is to have both of these to be the same. If these aren't the same, you've done something wrong somewhere. Okay, so then I rewrite this as this 2x minus that 3, and then I got x plus 3 equals 0. Now, based on the product rule, the a, b equals 0. If a, b equals 0, then a equals 0, and then b equals 0. Okay? So I can say 2x minus 3 equals 0, and x plus 3 equals 0. Let's do the x plus 3 first. It's simple. Subtract 3 from both sides, and one of my x values are going to be negative 3 to solve the quadratic equation. And then I add 3 to both sides. 2x equals 3. And I divide both sides by 2, getting me x equals 3/2. So I have two answers here. I have, if I do my brace, 3/2 comma negative 3. And that would be my answer. 3/2 comma negative 3. Okay, continuing on. If I look on this next one, it says graph each equation. So if I'm going to graph this first one, how do I graph a quadratic equation? I got to get the vertex. Negative b over 2a. So the opposite of b, would that be negative? So again, I have a, b, and c up here. What's the opposite of b? The opposite of 8 would be negative 8 over 2 times 1, which equals negative 8 over 2, which is negative 4. That is the h coordinate of the vertex. Now let's go find the k coordinate of the vertex by plugging that back in to x. So I got x squared plus 8x. I got y equals x squared plus 8x plus 15. So plug that back in. Y equals negative 4 squared plus 8 times negative 4 plus 15. And then from there, I got y equals 16 minus 32 plus 15. Well, 16 minus 32 would be y equals negative 16 plus 15, which will give me y equals negative 1. So if I get y equals negative 1, so I got negative 4, negative 1 is my vertex. Negative 4, negative 1 is my vertex. So I can put that point there. And now I'm going to follow A. I'm going to follow whatever this right here is to complete the rest of my graph. Notice this one is just 1x squared. So from here, I'm going to follow that x squared coordinates. 1, 1, 2, 4, 3, 9. So from the vertex, I'm following these coordinates. So right 1 and up 1. Right 2 and up 4. 1, 2, 3, 4. Left 2, or excuse me, yeah, left 2 and up 4. 1, 2, 3, 1, 2, 3, 4. And I actually can go right 3, 1, 2, 3, and up 9 will be at the very top. And then likewise over here, right 3 and at the top. Therefore giving me this parabola. Should look something like that. Again, over here, that A, once you find your vertex, look at the A. Notice what A is doing. It's actually negative, so that means it should be flipping down. It should flip across the x-axis. Going down here to number 13, simplify 7 minus 2i minus 4 plus 4i. Well, when you're just adding and subtracting numbers with numbers that are complex, you're just going to literally subtract the first terms. 7 minus 4 is 3, and then you're going to subtract the second terms. Negative 2i plus 4i. negative 2 plus 4, which should give us a positive 2i here. Excuse me. I was looking at that. That didn't look right. Sorry. Negative 2 minus 4. I said that wrong. Negative 2 minus 4. Your 7 minus 4 is still 3. But negative 2 minus 4 is negative 6. So negative 6i. I'm glad I caught that because I know some of you all would have gave me trouble over that one. So you're just basically subtracting the first terms, subtracting the second terms, but make sure you do your subtraction right. Over here, you're just adding the first terms, adding the second terms. And again, you're not multiplying, so you're not getting anything squared. You're just keeping the, let me go ahead and work this just so we'll make sure we're clear. So we're going to add the first terms, 6 plus negative 8. Well, 6 plus negative 8 should give us, or 6 minus 8 is another way to look at it, would be negative 2. And then you say negative 7 plus negative 7. That's like saying negative 7 minus 7. That would give us a negative 14i. So you're not combining, the i's would just come together. They're like terms. So negative 2 minus 14i. Again, that's 6 plus negative 8, which is just this right here turns to minus 8. And then the other one is negative 7 I plus negative 7i. And this right here is a minus. So negative 7i minus 7i, which gives us the negative 14i. So that's where we're kind of getting all those answers from, just to make sure you're clear on that. 15, you want to multiply negative 2i and negative I first. So when you do that, you get a positive, because the negative times the negative is a positive. You get positive 2i squared times negative 1 minus 5i. However, whenever you see that I squared, you need to know that I squared is equal to negative 1. So change that to negative 1. Say 2 times negative 1 times negative 1 minus 5i. Well, we can go ahead and multiply this, and that gives us negative 2. Negative 1 minus 5i. Notice that negative 1 minus 5i hasn't changed anything. We're just cleaning this up. And again, I squared just changes the sign of its coefficient. So it's negative 2. And then we can distribute from there. And I get negative 2 times negative 1 is a positive 2. And then negative 2 times negative 5 is a positive 10i. So 2 plus 10i there. Looking at 17, 6 minus 4i squared. Again, that's not raising each factor to the power. That's doing this. 6 minus 4i times 6 minus 4i. The exponent tells you how many times to multiply the base by itself. It says we add exponent 2, multiply the base by itself twice. So this is when we FOIL this. Okay, so FOIL first. 6 times 6 is 36. Outer, 6 times negative 4i would be negative 24i. Inner, 6 times negative 4i would be, again, negative 24i. And then last would be negative 4 times negative 4, which is a positive. 4 times 4 is 16, and I times I is I squared. Well, that leads us to 36 minus 48i. And again, that I squared, think about that as being negative 1. It just changes this sign to negative 16. Again, that math comes from this right here. 16 times I squared. I squared is negative 1, so that's negative 16. That's where that math's coming from. And then from there, we can fix that. 36 minus 16 would be a 20 minus 48i, and I'm writing the 21st because that's the a plus bi standard form of complex numbers. Okay. Hope that helps. There's some other practice problems there. You got your answers. Continuing on. If I'm looking at number 19, so if I'm looking at 19, basically here's a rule when you're simplifying a quotient of complex numbers. If it says to simplify this, you just want to multiply times the complex conjugate, which is basically the opposite of this, okay? So that's 10i, and then come up here and say 10i. And you're multiplying all this, so multiplication, that equals 10i all over negative 10 times 10 is 100, or negative 100, and I times I is I squared. Now we just talked about what that I squared does. It changes the sign of the coefficient. So we can rewrite this as 10i over positive 100, and then the I squared is gone, because that I squared turns to negative 1. Negative 1 times negative 100 is 100. From there, we can just simply simplify. 10 goes into both of those. 10 goes into 10 one time. It goes into 100 10 times, so 1 over 10. And make sure you keep that I up there, or just simply I over 10. Okay? Likewise with the bottom, what we're going to do at the bottom is we're going to multiply times the complex conjugate. Now the complex conjugate of this is negative 10 minus 2i. Okay, and up here likewise negative 10 minus 2i. And you may be saying, well, whoa, I thought you said it's the opposite. We're just changing the middle sign right here. We're not changing the negative 10 because that's not necessarily its complex conjugate. That would be the whole expression's opposite, but not the complex conjugate, which is just this sign. And you may be saying, well, that's confusing because we didn't change we changed the negative 10 up here. But keep in mind, if we put that in standard form, it'd look like this: 0 minus 10i, and the complex conjugate of that is 0 plus 10i. So essentially, but we're not including the zeros here. So it's the same principle here. You're keeping that as negative 10. You're just changing this sign. So the complex conjugate. From here, we multiply up top. The only thing we got to do is distribute. So net, and again, you can kind of put that in parentheses there. 5i times negative 10 would be negative 50i. And 5i times negative 2 would be negative 10i. I'm going to put that all over. And then on the bottom, anytime you're multiplying complex conjugate, you can use FOIL, F-O-I-L, first, outer, inner, last. Or you can just do this, a squared plus b squared. And that will give you your answer as well. If you're looking at a squared, a right here is negative 10. So negative 10 squared plus b squared. B here is 2. Negative 10 squared is 100. Plus 2 squared is 4. So 104. So we'll look at this and we'll say 104. Okay. And then if I'm looking at my answer key, something doesn't look right. Oh, I got it now. I see what it is. Sorry. 5, and I'm sure some of you are like screaming at the window, you didn't multiply 5i and 2i. So 5i and 2i is negative 10i squared, which makes it negative 50i plus 10 all over 104. Now, so let that be an example to you. Again, obviously I went back and I found it, but make sure when you're multiplying that, make sure you include those I times I, which is I squared. And then from there, we can actually simplify because 2 will go into all those. So 2 will go into negative 50. So again, 2 goes into all these, so we're dividing everything by 2. So that would look like this. 2 will go into negative 50, negative 25i times 10 divided by 2 is 5, and then 104 divided by 2 would be 52. Now, you'll notice on your answer key, you really don't see that as your answer, and that's because they put it in standard form, which would be what it is on the test, a plus bi form. And when it's in that form, we rewrite it as 5 over 52. We basically just split these into fractions. 5 over 52. And then minus, because that minus 25, 25i over 52. And that's technically standard form. Just wanted to kind of bring that to your attention. All right, almost done. Looking at 23, n squared plus 12n minus 25 equals 3. So if I'm looking at that and it says do it completing the square. And I told most of you don't worry about trying to do that when completing the square, because anytime your coefficient is not 1 when completing the square, it can be very challenging. So we don't have to worry about that. So you can mark that out, or you can just simply use the quadratic equation. So here, if we're doing this by completing the square, what we want to do is to add this 25. With completing the square, we wanted an ax squared plus bx plus or equals c form. So add 25 to both sides. That cancels. N squared plus 12n equals 28. And then with completing the square, we want to add b over 2 squared to everything. N squared plus 12n plus b right here is 12. 12 over 2 squared to both sides equals 28 plus 12 over 2 squared. Well, n squared plus 12n, so n squared plus 12n, 12 over 2 is 6, so, and then 6 squared is 36, equals here 28 plus 36. From there, we ask ourselves, or we can go ahead and say n squared plus 12n plus 36 equals 28, and 36 would give us 64. Now, if we're looking over here, is this a perfect square trinomial? Remember those steps we did? You look at your first and third terms, 1 and 36. What are they the perfect squares of? 1 and 6. Double that number. Is it the middle term? Is 12 the middle term? It is. So this is a perfect square trinomial. So what that means is I can rewrite it as this. N plus, the sign comes from there, and whatever this is the perfect square of. It's the perfect square of 6, so n plus 6 squared equals 64. Sounds like a N64 stuff. 007. That's old school. Y'all don't know about that. Then from there, we just take the square root of both sides. That cancels. N plus 6 is equal to plus or minus 64, or excuse me, plus or minus 8. And then subtract 6, n equals plus or minus 8 minus 6. We can separate that as positive 8 minus 6 and negative 8 minus 6. 8 minus 6 is 2. Negative 8 minus 6 is negative 14. And for number 23, we get 2 comma negative 14. And those are braces. We got to put braces because it's not a coordinate. It's just two x values. That's that. Then let's look at number 25 real quick. With number 25, it says solve each equation using the quadratic formula. Luckily, this is in quadratic form, a, b, and c. So a is 3, b is 8, and c is 5. So I got opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just going to start plugging everything in. So the opposite of b is negative 8 plus or minus the square root of 8 squared minus 4 times a would be 3 and c would be negative 5 all over 2 times a, which is 3. From there we got negative 8 plus or minus the square root of 64 minus negative 12 times or actually it's going to be a positive because the negative here, negative 12 times negative 5 would be a positive 60 all over 6. That leads us to negative 8 plus or minus the square root of 124 all divided by 6. And you all kind of know how that works within itself. You got to come bring 124 to the side and say what are the what multiples will go into 124. Okay. So if I just start looking what will go into 124, I know 2 will. Well, let's see if 4 will. 4 would be valuable. 4 and 31. So anytime you have one that has a square root, just go ahead and square root it so we know it changes to that. And the square root of 4 is 2, so 2 squared of 31. And then you can ask yourself, well, anything going to 31? It won't. Just 1 and 31 in itself. So we got negative 8 plus or minus 2 square root of 31 all over 6. From there, 2 goes into all those. 2 goes into negative 8, negative 4 times. 2 goes in itself once, so we can just leave that as blank. Bring your square root of 31, and 2 goes into 6 3 times, giving me negative 4 plus or minus the square root of 31 all over 3. And again, we could separate that out if we wanted. Looking at the last one, let's look at number 27, and then we'll finish. 2n squared plus 6n plus 12 equals 6. So subtract 6 because we want it in ax squared. We want it in ax squared plus bx plus c equals 0 when we are using the quadratic formula. Okay? So here, subtract 6. When we do that, that cancels. 2n squared plus 6n. 12 minus 6 would be positive 6. Equals 0. It'd be a nice thing if this could factor, because even on the test, even though it says quadratic formula, you can still use factoring, but even still here, 2 times 6 is 12. No factors of 12 would add to be 6, so that means we have to use quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And again, we're solving quadratic equations here, all right? So within that, a is 2, b is 6, and c is, with the subtraction over, c is 6. So negative 6 plus or minus the square root of 6 squared minus 4 times 2 times 6 all over 2 times 2. That takes us to negative 6 plus or minus the square root of 36 minus 8 times 6 is 48. Right, 8 times 6, or negative 8 times 6 would be 48. Good. And then all over that would be 4. And I get negative 6 plus or minus 36 minus 48 would be negative 12. Negative 12 all over 4. And when you see that negative, now, you know, again, this is where we should know a few things about that. So let's bring the square root of negative 12 over here. What are the factors of negative 12 that I could rewrite it? Well, we got 2 and 6, 1 and 12, 2 and 6, 3 and 4. 4 has a perfect square root, so I could say the square root of 4 times the square root of 3, but one of them has to be negative in order to satisfy this. So make the 3 negative because we want the 4 to simplify to the square root of 4 is 2. So 2 square root of negative 3. And then the square root of 3 would then simplify to be just simply 3i then. But let's put this in, then we'll kind of go from there. So then it becomes negative 6 plus or minus 2 square root of negative 3 all over 4. 2 goes into all of them. 2 goes into negative 6. Negative 3 times. 2 goes into itself once. And then it'll go into 4 twice. Then from there, then rewrite the square root of negative 3 as the square root, I times the square root of 3. We don't say square root of 3i. So then from there, we can just simply say negative 3 plus or minus I square root of 3 all over 2. Hope this video helps. Looks like we're coming in at 34 minutes. Hope it helps. I don't mind answer maybe 5 minutes of questions or more before we start the test, but I want to get in and get going. If you have any questions, email me, hit me up, whatever it is. Thanks. Have a good night.